All right, we'll get going here. Thanks everyone for joining the Weatherlogics Summer Outlook. Just a reminder that this meeting is being recorded so people can view it later on our YouTube channel. If anyone has any questions throughout the Summer Outlook that Scott's presenting, feel free to send them in the chat and then we'll address those questions at the end of the presentation. I think that's all for the housekeeping items. Just a short introduction now about Scott Kaler. Scott is the president and chief scientist at Weatherlogics. He attended the University of Manitoba, where he completed his bachelor's and master's degrees in meteorology. In his current role as chief scientist at Weatherlogics, Scott conducts weather research and develops tools to help clients plan for all types of weather conditions. This includes new methods to improve weather prediction and the analysis of past weather events. Despite his research focus, Scott still enjoys forecasting day-to-day weather and is often involved with preparing forecasts in high-impact weather events. So I'll pass it over to Scott now.
Thanks, Matt. I'll just bring up my presentation here and make sure you can see that all right. How does that look?
Looks good to me.
Okay, great. So for today, we've got a few topics. Of course, the summer outlook, but we'll also take a look back at 2023 and how the weather behaved last year. Then going into this winter and how El Nino has been affecting weather. And lastly, the outlook, especially focused on the impact of a waning El Nino. So throughout the presentation, there'll be a lot of references to normal weather, especially normal precipitation. So I thought I'd just start with a quick map here showing you what normal means, because we're talking about the entire prairies region today, and normal varies quite a bit. So this map is showing you what is normal precipitation from, I believe, the months of, my bar is blocking it, but I believe it's the months of April through August. Yeah, I can see it now. And as you can see, the lowest precipitation normally on the prairies is in Palliser's Triangle from southeastern Alberta into southwestern Saskatchewan. In some of those areas, especially around Medicine Hat and Brooks, normal precipitation for that time period can be as low as about only 200 millimeters or 8 inches. If you move eastward into Manitoba, the far southeast corner of Manitoba sees about double that on average. So there's quite a difference. And so generally speaking, you can kind of say that precipitation increases from west to east across the prairies. The only exception would be kind of the foothills of Alberta up into central Alberta. It's a little bit higher, but elsewhere, pretty much from eastern Alberta and then moving east from there, that's a pretty good rule to follow. So looking back at last year, the big story for most of the prairies was very dry conditions. And so this is the map showing March through May precipitation. And the map is showing in brown areas that had less than normal, and in green or teal shades more than normal. So broadly across the prairies, it was a pretty dry spring. There were a few pockets that had some more moisture, but those were pretty few and far between. Moving into the summer months, June through August, things in most of the prairies either remained dry or got even drier. So from southeastern Saskatchewan through southern Manitoba, it was a very dry summer. The only exception on the prairies was in central Alberta. There was an active storm track. And interestingly, while a lot of the southern and southeastern prairies were very dry, parts of central Alberta were actually very wet to the point that there was flooding in the Edson area from all the summer rain. The areas in red are close to record dry conditions, so that's really telling you how dry it was. But as we get into the summer, though, you do see the little pockets of higher amounts scattered in. So even in some of the drier areas of Saskatchewan, there are little circles with heavier amounts, and a lot of that can be attributed to thunderstorms, which are very localized in nature. So by August of last summer, the prairies were generally dry. I think this map is probably quite generous in how soil moisture is assessed for A lot of areas, especially Saskatchewan, where it's showing that it was just only slightly drier than normal. So that kind of bright green is just slightly below normal. Soil moisture in Manitoba, a lot drier than normal, and also in parts of Alberta, drier than normal, although eastern Alberta. Here it's showing just slightly drier, but again, that's probably a bit optimistic considering what we saw during the summer months for lack of precipitation. Now, as we moved into the fall, things did improve a bit. We did see a little more precipitation, but it wasn't really wet by any means. Some of the wetter areas were in southeastern Saskatchewan, also around Calgary, and there were some wet areas in Manitoba, but it wasn't a real game changer. So really, we're talking kind of generally anywhere from slightly below normal to slightly above normal. No major events like we saw some years in the fall, like 2019. And in Manitoba, we do have a fall soil moisture survey. So this is what was taken by Manitoba Agriculture in the fall. Basically, if you're in the reds, you're really dry. Dark green is, pretty wet, or not necessarily really wet, but at least soil moisture is near the upper end of the range. Again, I think this map is a little bit optimistic for soil moisture. There definitely was some improvement in the fall with more precipitation, but talking to agronomists and farmers, I think generally people think that this probably is showing more moisture than is actually in place or was in place in the fall. So now how about winter? This winter has been, of course, dominated by El Nino. And El Nino refers to the water temperatures in the Central Pacific Ocean. You see those in the black circle here. Whenever El Nino is in place, it affects global weather patterns because of how large and expansive ocean this is covering. The Pacific is the largest body of water on Earth and one of the largest, well, the largest single region, if you want to call it that, on Earth. And therefore, it has a big impact on weather patterns. So you can see here that when this water temperature map was taken at the beginning of January, El Nino was around its peak, and so those temperatures were quite a bit warmer compared to normal. So how does El Nino affect our weather? Well, this winter it was pretty evident. So what it tends to do is shift the jet stream farther north across Western Canada. And this winter it was actually a really strong one, so that jet stream was shifted north over most of Canada. Especially early in the winter, pretty much all of the country was warmer than normal. Kind of lately, we've started to see that break down a little bit, so the whole country hasn't been on the warm side all the time. But kind of the dominant influence of El Nino tends to be the jet stream shifting farther north over the western part of Canada, bringing warmer winters to Western Canada. So these maps are showing you what the winter impacts would be. Now, is change coming? We've heard that El Nino is starting to weaken, and there's pretty strong signs at this point that we're moving toward a La Nina pattern. And La Nina is when those waters in the Pacific cool and more colder than normal, which tends to bring the opposite effects, so colder and more snowy winters for Western Canada. So in the winter, weather tends to, or the kind of overall winter weather pattern tends to be more predictable because the jet stream is stronger and things like El Nino or La Nina play a bigger role. The impacts are a little bit less clear and correlated as we move into the spring, summer, and fall months, but I'll talk about how we're expecting the weakening El Nino to play into our prairie weather for the growing season. But so you're aware, there is this change coming, and this is the official forecast from the American Weather Service. So where you see red bars, that's a high chance of El Nino. So the red bars on the left of the graph are for the months of January, February, March, and February, March, April. Now, this third bar, this is the forecast for March, April, May. So you see the El Nino forecast is starting to show it being a little bit less probable, but still, more likely than anything else, around 75% chance El Nino lasts into the spring. But then you see by kind of late spring into summer, those red bars really drop. So the chance of El Nino still being in place this summer is very slim. But then you also see the blue bars starting to go up, which means the chance of La Nina is increasing. So right now the forecast is suggesting quite strongly that El Nino is fading and will transition into La Nina either late this summer or next fall. So that is likely going to be the influence next winter, but it won't probably be a huge player this summer. It's probably still going to be in the development phase. So, of course, this winter, it's been interesting because we've had generally a lack of snow cover, but we have had some notable snow events. The thing is, though, it's snowed and then it's melted and then it's snowed again and melted. So the actual amount of snow on the ground has never really been that high across the prairies. In fact, it's probably at its highest point for almost everybody right now, except where it's melted because of all the snow that was received in from eastern Alberta through Saskatchewan and Manitoba with a series of winter storms last week. So here, the image showing snow cover on January 3rd indicates that for most of the prairies, there was very little snow cover at that point. This map is showing you what is the moisture equivalent of the snowpack. So if you were to melt the snow, how much moisture would come out of it. And those gray areas indicate anywhere from about 0 to 25 millimeters or 0 to 1 inch. So very little moisture early January. Now in March, with the snow that we got, now we've got a decent amount of snow, especially in the northern grain belt of Saskatchewan, into eastern Saskatchewan and western Manitoba. Southern Alberta is pretty much snow-free now. In the Red River Valley of Manitoba, the southern valley is pretty much snow-free. The northern valley still does have some snow, and southwestern Saskatchewan also mostly snow-free. So it's the more northern parts of the prairies at this point, at least the northern agricultural areas, I should say, that have the most snow cover. But at this point, it's still not. I mean, it's a lot better than it was, but overall snowfall for the winter is nothing overly unusual. It's just it's come a little bit late this year. All right, so now talking about the summer outlook and how do we make the summer outlook? So when we're doing a seasonal forecast, the forecasting process is quite a bit different from just forecasting day-to-day weather. When we're looking day to day, we can look at kind of what the weather is like kind of across the prairies, what weather systems are moving through, and so on. But when you're forecasting months in advance, really you're looking at global factors that will um, cause the weather pattern to behave one way or another over the course of an entire season. So that's why we always talk so much about El Nino and La Nina, because these are such big global factors. El Nino doesn't mean every day of the winter is going to be warm and dry, but that's broadly the story. Same with La Nina. It doesn't mean every day next winter is going to be cold. And indeed, we may still get some warm weather next winter. Just like this winter, we did have some occasional cold spells. That doesn't mean El Nino is gone. That just is because El Nino is a global driver of weather patterns, and those weather patterns are always changing. So you have to look at it kind of on average rather than just on a day-to-day basis. There's other things that we can use, weather models. There are long-range weather models, which are supercomputers that forecast the weather. Some of them are useful for kind of, again, broad trends, but they're not always that accurate. You kind of have to look at a lot of them and see if they're all telling you the same thing. There's also atmospheric oscillations. Probably one of the ones that we talk about the most is the polar vortex and how often that wobbles outward from the pole, giving us those Arctic outbreaks. This winter, that's happened very little, but some winters that's happening all the time. And also solar cycles, that's an interesting and controversial one, but there actually is a correlation between the cycles of the sun and how much energy it's producing and weather. Why exactly that is can be a bit unclear at times, but it's something to watch because there is some correlation there. So this slide is showing you analogs for this year. An analog is basically just a year in the past that seems to be similar to the year that we're expecting coming up. So 2007, 2010, 2016, 2019 all appear to be similar to 2024 for the summer. Now these maps, unfortunately, they all use different legends because over time the color scheme changed. But generally, if you're seeing kind of the purples and blues, those are wetter than normal weather. So these are April to September precipitation. And then if you're seeing kind of the yellows and browns, that's drier than normal. So the 2010, 2016, 2019 were broadly wet years across the prairies. 2019, there was some dry areas, especially southeastern Alberta and kind of central Manitoba, northern Grain Belt of Saskatchewan. 2007 was quite variable because there was a lot of thunderstorm activity. So there were some dry areas, but also some very wet areas. And then 2010, 2016 were pretty much wet across the board, except maybe in a little bit of central Alberta. So really the story for these analogs in terms of precipitation is generally looking at wetter weather. The strongest signal for wetter weather tends to be on the eastern prairies, but even in Alberta, the signal is definitely, if anything, it's not dry. It's kind of hinting at more normal precipitation, but kind of in general, this El Nino that is waning tends to favor wetter summer weather. So then what about temperatures? These are the same years, but what was the temperature pattern those summers? So if you're seeing blues, that means it was colder than normal, and greens and yellows, reds, those are warmer than normal. So this one is showing for, again, most of the prairies tended to be on the warmer side. 2010 was definitely cooler in southern Alberta and southern Saskatchewan. But really for agricultural areas, with the exception of that year, we're talking mostly warm. 2019, a little bit of cooler weather in the northern Grain Belt and central Alberta. But if we look at Manitoba, every year is warm except 2010 is kind of normal. And then for the western prairies, it's a little bit, the signal for warm weather is a little bit weaker, but it's still kind of leaning more toward the normal to slightly above normal side for temperatures. So for the forecasts themselves, we categorize it into three groups: above normal weather, or below normal. If we're forecasting above normal, that means 20% or more above what the normal would be for your area. So let's say your normal precipitation is 300 millimeters in the growing season. That means 360 millimeters or more would be above normal. And then on the flip side, below normal, 20% or more below normal. So if normal was 300, then you would expect 240 millimeters or less. So the summer temperature outlook, this tends to mirror kind of the analogs where we're expecting that the signal's a bit stronger in the eastern prairies for warmer weather. Some of that reaching a little bit into southern Alberta as well. But for most of Alberta and parts of the northern Grain Belt of Saskatchewan, more normal temperatures. And then as you get farther south and east, signal for warmer. Now, we're not expecting a really hot summer, wall-to-wall heat, but just warmer than normal. So if we look back last year, let's say, for example, last summer, um, I'll just use Manitoba as the example. June was really hot, July was cool, and August was normal. So that as a whole averaged out to about normal. So this summer we're expecting probably less of that really cool weather. So probably more normal generally, but with some occasional bouts of heat. We're expecting it to start out more on the warm side, normal to above normal temperatures in the spring. That has a lot to do with the lack of snow cover. If you don't have snow cover, the ground absorbs a lot more sunlight, especially in March and April. The sun is already quite strong, and so the lack of snow cover allows things to warm up faster. Then as we get into summer, still kind of in that normal to above normal range, so giving us as a whole for the growing season generally normal to above normal temperatures. So now precipitation. This is the good news slide for most folks who are looking for rain. So with waning El Nino, it's a pretty strong correlation to wetter weather across the prairies. This is due to two factors, and both of them are linked to the jet stream. So as El Nino weakens, we tend to get the jet stream cutting into the Pacific coast, kind of from lower the southern BC down into the west coast of the US. When that happens, we tend to get stronger weather systems that form along the mountains. So the Rockies from Alberta down toward Colorado. That means a greater chance of things like Colorado lows. Those will bring more steady rainfall. And also with this jet stream pattern, if that jet stream pattern continues into the summer months, it carries weather systems with it across the prairies. Those systems can then generate thunderstorms with the heat and humidity in place during the summer. So the wetter weather will come likely in a combination of more low pressure systems bringing steadier rainfall and also more thunderstorm activity. So lastly, the thunderstorm outlook. Just note here that this map is compared to last year as opposed to normal. We compare our thunderstorm forecast to last year just because it's really not easy at all to try to compare thunderstorms to normal. They're so hit or miss, and we have so little good data on them that that's not really a good way to make the forecast. So we're just comparing to last year. Bear in mind that last summer was a very active summer for thunderstorms and hail in Manitoba. It was not very active in Saskatchewan for hail. In fact, one of the slowest hail seasons we've seen in a long time in Saskatchewan. And Alberta was kind of around normal. So Alberta did see a number of strong thunderstorm events and hail, but nothing unprecedented. So for this summer, we're expecting more active weather from southern Alberta into Saskatchewan. So that will be definitely an uptick for Saskatchewan that had not a lot of activity last year compared to, what you would expect. For Manitoba, kind of more of the same. So another stormier summer, so similar to last year. And the same thing with most of Alberta, especially the foothills into central Alberta, similar to 2023. So fairly typical thunderstorm year. I mean, the foothills of Alberta is the most hail-prone part of Canada by far. And so we're expecting more of that this year. And just a little ad here. Our next webinar will be on hailstorms in Canada. So if you'd like to learn more about our work in both forecasting hail, tracking hailstorms, keep an eye out for that. That will be on April 24th. And we look forward to talking more about hailstorms at that time. And we'll probably also dig a little more into what we're expecting this year in terms of hail. So that's what I have for my outlook today. Thanks for joining us. And now we've got some time for questions. So I'll turn it over to Matt. And Matt, feel free to jump in here with any audience questions.
Thanks for that, Scott. If anyone has any questions, feel free to send them in the chat. I see there's a couple questions already from Michael. So maybe we can start with those, Scott. First
Sure.
question that Michael has: do you think the effects of El Nino will enhance the precipitation this summer? And he refers to the CFS V2 model having some strong signals for a wetter summer. And he also notes that the El Ninos transitioning to La Ninas were also wetter summers. So I think from what he says, he kind of agrees with what your forecast is. Maybe you could comment a little more on what he's looking at.
Yes. So, Michael, what you're seeing is basically what I saw in making my summer forecast. So as El Nino tends to wane, that tends to be a lot of the more active summers on the prairies for precipitation. So I showed those analog maps, which showed a lot of those years after El Nino were a lot wetter. And so that's a big factor in the forecast this year.
Okay, thanks for that, Scott. And Michael had one other question. This one refers specifically to tornadoes, and he is wondering what the tornado season will look like this summer. What do you expect for tornado numbers this summer?
So for tornadoes, that would be basically related to our thunderstorm forecast. So we don't directly forecast the number of tornadoes. It's just simply not possible to do reliably. But I think it's safe to say if you're expecting more thunderstorm activity during the summer, it would also be a reasonable assumption to expect more tornadoes as well. I haven't made that forecast specifically, but I think it's just a reasonable connection to make.
Okay, thanks for that. One other question in the chat that just showed up. Jeff has a question. How is AI going to affect weather forecasting?
Yeah, that's a great question, Jeff, because that's kind of all the talk right now in the world of meteorology. So AI, it's already starting to forecasting. Many organizations have produced weather models based on AI. Everyone from Google to Huawei to the Europeans, they've all produced AI models. Now, as of right now, I think the main impact we're seeing is that these AI models are giving us more lead time on major storms. So for the prairies, the big storm that hit at the beginning of March, we saw that the AI models were able to predict that storm about 2 days earlier than the older, what I'll call older fashioned weather models, although we still use them all the time. So that seems to be the big impact right now. That also has shown up in forecasting for hurricanes, which have now extended lead time. We're not yet seeing as good of an impact with weaker weather systems and like short range details of weather. But I think over time, as these AI models improve, we'll start to see other things. I'm hoping precipitation forecasts will get better, things like thunderstorm forecasts as well. But right now, the main impact is on major storms, giving more lead time. But given how much progress has already been made, I see no reason why we won't continue to see more and more applications as they continue to improve.
Okay, thanks for that, Scott. Yeah, so better lead time, good news for everyone. Everyone's looking for better forecasts. So yeah, I will definitely improve that space, I'd say. Moving on, one other question here that just showed up. Ben has a question. With the 4 analog maps, were they trending wetter than normal or wetter than the year prior?
So those were all compared to normal. Ben mentions that the prior year tended to be drier locally in his memory. So yeah, these were all compared to normal. I showed the normal map at the beginning of the presentation. So it's a bit of a mind bender too, because if you're in Alberta, for example, a normal year might be a super dry year in Manitoba. But if you just think about where you are, it was compared to that.
Okay, thanks for that, Scott. Brendan Phillips just posted a question as well. Is there an elevated risk of late spring frost events?
That's a tough one because frost is something which is not necessarily connected that well to kind of the larger scale weather patterns. So I would say I don't think there's a strong signal one way or the other about that. The only thing I would say is that given the lack of snow cover and the potential for an earlier spring, that will allow the ground to likely heat up more quickly and maybe slightly mitigate the chance of those later frosts because the spring may start earlier, but that's still not a guarantee that there won't be a later frost. So I wouldn't bank on that one way or another, but it maybe would lean just slightly toward a lower chance because of the potential for an earlier spring.
Okay, thanks for that, Scott. If anyone has any other questions, feel free to send them in the chat. We had one other question here show up. Will it be a drastic pattern change from El Nino to La Nina, or is it going to be gradual during the spring? Like, is it going to be one big system that changes everything, or is it going to be gradual?
Yeah, that's a tough one to say. I think it may seem like there's one big system because they're probably with this transition. I mentioned that we're expecting a stormier pattern, kind of in spring and summer. So it kind of might seem that way, but that's not necessarily directly related to the transition from El Nino to La Nina. Just day-to-day weather isn't necessarily directly affected by those patterns, but given the chance for more storminess, that kind of might seem to be the case. So I guess the answer is, I guess in some ways the answer is yes to that question, but I wouldn't, from a science point of view, I wouldn't necessarily connect it directly to the development of La Nina.
Okay, and a couple other questions just showed up in the chat here. We'll start with Jason's question. Will we see overall higher humidity for most of the growing season as well? I think he's referring to your higher than average precip forecast. So maybe you can address that.
Sure. So if we assume that that forecast is correct and we do get a wetter summer, then yes, there would definitely be higher humidity. Our crops release a ton of humidity during the summer when they're growing, and the more soil moisture they have access to, the more moisture they can release to the atmosphere. So if you look back historically at humidity, you'll see some of the most humid summers were summers where we had really healthy crops, which largely came from wetter weather.
Okay, thanks for that. Mike had a question. What's a forecast for March into April? Do you think there's going to be any cold weather outbreaks? And when do you expect the big heat to come in?
Well, for kind of the rest of March, unfortunately, if you're looking for spring, it does look like a bit of a setback coming. So this week on the prairies has been on the warmer side, but it does look like we're going to be trending colder, especially next week and likely lasting pretty much for the rest of March. So second half of March likely going to be colder. Then the signs point to warmer weather returning in April. So assuming that holds, with the lack of snow cover we've got, that transition could happen very, very quickly once a warmer pattern arrives in April.
Okay, good to know. Karen has a question on frost. So, any thoughts on if we will have an earlier spring or late fall frost? Maybe you can address that, Scott.
Yeah, I kind of talked a bit about the potential for a later spring frost. Um, sorry, I'm just rereading the question to make sure I've got it right here.
Yeah, basically, do you
Earlier
think
spring.
is there going to be
Okay.
an early frost? I guess this would be an early May frost or late April frost, or will there be any late fall frosts?
So as far as spring goes, I mean, in April, almost certainly we're going to have frost. That's normal. In May, the question is what happens in May, because that's kind of the month where some years you do have frost and other years not. So I kind of talked about how I didn't have a strong feeling on that, but given that it could be an earlier spring with a lack of snow cover, that would tend to lean a little bit toward the potential for or the lower likelihood of a later spring frost. As far as fall goes, uh, really too early to say on that. I couldn't give you a good answer one way or the other on what the fall frost outlook is.
And maybe just a follow-up question from me on that. If there is better moisture than expected, would you expect a later frost, or does that not have any impact on it?
If there is higher humidity, that would tend to lend itself a little bit toward a later frost, because if you have really dry air, it tends to cool more rapidly than a moister air mass. So now we're kind of connecting all sorts of things. We're assuming it's going to be a wetter summer and more humid summer, and then more humidity in the fall, which could maybe delay frost. So yeah, those are potentially connected, but again, I wouldn't totally bank on that because that's so far away.
Okay, thanks for that. And Jason has a follow-up question here. What can we expect as far as winds this coming season?
Um, yeah, I get asked about wind a lot, and the thing about wind on the prairies, it's just always it's always going to be windy on the prairies. Even years that maybe technically aren't that windy compared to normal still feel windy. So definitely expect there'll be very windy days. There's no question about that. Will it be windier than normal or less windy than normal? That's very hard to predict. That's not something I looked at specifically, but you could generally draw the conclusion that it could be a little bit windier if there's a lot of weather systems passing through, because those pressure changes are what cause wind. But um, yeah, as far as just generally what it's going to feel like out there, there's definitely going to be a lot of windy days. That's just always the case on the prairies.
So leaning towards windier.
Yeah.
All right. One other question here just showed up from Karen again. Does La Nina contribute to early fall snowfalls?
That's actually an interesting question, Karen. I have not studied that. Um, yeah, I don't want to answer it because I would want to do the research to see what the numbers look like. Um, just an observation. This past fall, we had a pretty snowy October in Manitoba last fall, even though it was an El Nino year. So El Nino clearly doesn't necessarily guarantee that there won't be snow and fall. But if you want, I could look into that. Feel free to send me an email later, and I could check for you.
Okay, thanks. I think that's all for the questions. If anyone else has a question, just post it in the chat over the next 30 seconds here. But thanks, Scott, for the presentation, and it was a good discussion.
So we just had one final
Oh,
question here. I'll quickly answer
yeah,
that. Can we
just
expect a regular length growing season, or will it be shortened for any reason? The potential for that, no, maybe before I start, growing season's defined as the date of the last spring frost to the date of the first fall frost. So given that we're expecting potentially an earlier spring with the lack of snow cover, that would tend to lead to a longer growing season. So that's what I would lean at this point, just on that basis.
Okay. A couple more questions here, just showing up as we in the session. So first one, Michael McGregor. Is there an increased risk in tornado outbreaks this summer because of how active it is?
Yeah, for that one, I would kind of go back to my earlier comment about the fact that we're expecting more thunderstorm activity, and that could be connected to more tornadoes. We don't forecast tornadoes specifically, so I wouldn't make a prediction on tornadoes themselves, but it's reasonable to say that more thunderstorms could lead to more tornadoes.
Okay. And Darcy has a question. Do you integrate with any farm weather stations? Good question.
So for those that maybe don't know about our services, Weatherlogics offers a weather forecasting subscription to farmers. So you provide us with your location, and then Matt or myself or some of our technology solutions will then produce weather information for that location. So do we integrate with farm weather stations? We don't integrate with hardware right now because we have other ways of getting weather data, either from public stations or from other technologies that we've developed. So we don't do that. But if you'd like to discuss that with us, feel free to again send an email, and I would be happy to describe how all of our stuff works.
All right. I'm not seeing any other questions at this point. So I guess we could wrap up, Scott.
Yeah, thanks again, everyone, for joining us. Good discussion, and all the best this growing season.
All right. Thanks, everyone. Talk to you later.